The use of forces in sports. Speed and velocity. Speed is defined as how quickly an object covers a distance. Velocity is defined as a direction. Units of speed and velocity are meters an hour, kilometers an hour, meters per second. Average speed equals distance travelled divided by time taken. Acceleration. Acceleration is defined as how quickly the speed of an object changes. Acceleration equals v minus u over t, or change in speed divided by time taken. In this short video clip, notice how, just before the tennis player hits the ball, his racket accelerates rapidly, i.e. his racket changes its speed. Forces. A force is a push or pull causing an object to undergo change. The unit of forces are newtons. There are three main effects that a force can have on an object: change of direction, change of motion, and change of shape. In every sport, forces take place, allowing us to perform. The sport I have chosen to use as an example is tennis. In tennis, forces are acting all of the time. In the video, you can visualize the forces acting on the tennis racket, ball, and on his body. Air resistance, gravity, change of shape, tension, lift, and velocity are all active at some point in tennis. Reaction forces. For every force applied, there is an equal force applied in the opposite direction. In tennis, the reason the player does not fly backwards is because the player's mass is much greater than the ball's, meaning that more force is needed to move it. Notice how, when the tennis player hits the ball moves, and the tennis player does not. This is because the tennis player has a much greater mass. In the last picture, you saw how some forces act on the racket, body, and ball in tennis. In the next picture, you will see similar forces acting elsewhere due to the type of shot and direction or movement. Other sports also use forces, such as skiing or snowboarding. In skiing, it is easier to spot acceleration, deceleration, and friction or drag. Momentum and collisions. The bigger the mass of an object and the faster it moves, the more momentum it has. If a skier is going very fast and is very big, it would be harder to stop that skier than stopping a small and slow skier. Momentum equals mass times velocity, or P equals mv. The units of momentum and collisions are kilograms times meters per second. Stopping distance. The stopping distance is found by adding the distance onto the braking distance. The bigger the momentum of an object, the bigger the stopping distance is. Thank you for watching. Made by me.